So, ma'am, I'm going to share with you how NBA game outcome predictor works. So, my project is doing this to predict which team is going to win for each NBA game in this season 2023 to 2024. Okay, the business problem is that despite the abundance of experts, analysis, and data online, it is quite difficult to predict which NBA team is going to win because of the ever-changing game dynamics and the factors that affecting game results. So I'll be just trying my best to predict. It won't be taking in all the factors into account because it's not possible to do that. And I will be just training my model on the game data. I'll be predicting win, lose. 1 for win, 0 for lose, using only historical game data. So it is a classification model. The success criteria of this model is that F1 score got to be 0.7 or higher. I use F1 scores because I want to take a harmonic mean of both precision and recall, taking both false positive and false negative into account. I don't want any biases towards them. So I'll be collecting data from sport data IO, but I only be doing on game data, not player data or team data, because they are dynamic because the player and the team can move around, so it's difficult for me to collect them. Game data also has enough features to be collected already. Since I'm only analyzing this season's data, there's not a lot of games yet, around like 600, 700 plus games. So therefore, too many features we also need to overfitting. So I'll be importing the libraries first. Next, I'll be doing the data collection from Sport Data IO. So as you can see, I collect every game since the start of the season, 24 October until 27 January, which is yesterday. So as you can see, there's a total of 67 columns and a lot of 1,400 plus 1,300 plus rows. So there's too many columns, and I will be removing them, especially all the IDs, names which are irrelevant to the prediction. So the day and date time and also fantasy data by the fans. Okay, I'll be updating and exporting them as CSV file. Then I'll be importing them again. So as you can see, there's still quite a number. There's still 40 plus columns which I'll be removing later on. Okay, these are the description of each column. You can take a look. Yeah, there's still too many columns and there's only 1,344 rows. So over here, we can see that we have 4 rows with missing data for possession and 1,344 missing data for these rows for these columns. So this means that there's no data in this column at all. So I'll be removing all these offensive percentage of those to these columns. So I'll be removing the 4 rows with no possession data and also these columns. Yeah. So later on. So next I will be checking the skewness. And as you can see, all of them are pretty, normal distribution. And only these 4 have positive skew, positively skewed. Okay. So yeah. Next, I will be removing all the missing values as you can see. So there's no more missing possessions really. Remove the 4 rows. And also all the no data column also remove them. Okay, so duplicated data, there's no duplicated data at all, so I don't have to remove any. Okay, so I will be only keeping these 10 columns and the rest I'll be removing them based on context. Why? Because most of them are repeated things like they mean the same thing. Like for example, for points, right? It can be all these things are represented are specific things of points like field goals made, field goal attempted. So all of them can be summarized by points. So I'll be removing all these columns. There's too many columns really. So it's going to overfit. There's so many. So yeah. So these are the things that are left. And I will continue on data exploration. As you can see, the numbers of wins and numbers of lose are equal because it makes sense because every game there's going to be one team that loses and one team that wins. So it's balanced data, so I don't have to, oversample or undersample. Okay, next you can see that the median for the point for win is greater than lose. Makes sense because the winner has more points than the loser. Okay, however, you can see that the possession for both lose and win is the same. Why? Because when we see the possession, they're actually taking the entire game into account. So it's not for the team itself, it's for the entire game. So it means that this possession thing, there's no use to the prediction at all. So I'll be removing the possession column later on. Yeah, so over here I'll be showing like the box plot for all this. So we can see that rebound is still effective percentage, all this, right? Their wins are greater than the lose, makes sense. And for turnover, the lose greater than win makes sense also because the more turnover you have, the more likely you're going to lose. So we can also see that as outliers, and can, analyze which of the outliers over here. Okay, so yeah, this is a win and lose, comparison chart, bar chart for each team. So you can see Boston Celtics have the most numbers of wins right now in the season. Okay, so yeah, for the part 2 of data cleaning, I have already addressed missing data, duplicated data. Data is balanced, so there's no need to do oversampling. And all these outliers just now I'm talking about, right, they actually contributes to the win or lose. There's only a bit of, they are not very extreme, so I won't be removing them. And also the data, right, for numerical data, there are all the skewed data, right, all the columns are already removed already because they are irrelevant. So there's no need to, normalize any more columns because everything's are normally distributed already. So what is left to do is feature engineering. But before feature engineering, I have to select a feature first, right? So remember the possession for the correlation matrix, it also shows that possessions have 0.0 correlation coefficient to it. So there's no point of having possession. So I'll be removing possession. Then after which, yeah, I'll be doing feature engineering. First, I will be scaling all the numerical data using the standard scaler. Okay, and after which I will be doing, one-hot encoding for categorical data so that the model is able to predict well. Okay, and then after that, I'll be doing training. So I'll be training these 9 models. And all these 9 models will be trained with hyperparameter tuning, also T4 validation to ensure that we search for the best parameter, the most accurate model that is the most, can also generate generalized well to new and unseen data. So F1 score, I selected it, which I said earlier already, as the performance measure. So the success criteria is 0.7 or higher. So first I'll be splitting into 80-20, the test set and the training set and the test set. Okay, then after that, you can see logistic regression and SVM as the best F1 score, and they met the criteria with this parameter. Okay, so let's further tune it and see how accurate they can go. So after we tune, right, the accuracy doesn't improve a lot. So this means that the models already reached like their maximum capability. So I'm considering an example method perform stacking both of them to create a stack model, see how accurate it can go. Okay, then validation, I'll be putting them to test data, all these 3 models, the stack model, the logistic regression, and SVM, and we can see that, the stack model has the best F1 score of them. Okay, and there's also no sense of overfitting because for the testing data, right, they're performing better than the training data. Okay, so next, so we got configuration matrix also, classification report also, take a look, ROC curve. See, all of them have a similar ROC area under curve, around 0.879. So all of them are pretty similar in terms of the result. So if the best model, if I want to select, is the stack model, because it has the highest F1 score of all of them, and it's the main performance metric I will be using. So all 3 of my main models met the success criteria. So my project is successful. However, right, this project can only be used using in-game data. So if you want to predict which NBA team wins, you need to feed in-game data, and our model has approximately 73% accuracy predicting the correct result. Yeah. So, but if I want to predict the game 2 days later, I cannot predict which team is going to win because only when the game started I can predict using the in-game data as the input parameter. So the best time to use our model is during the halftime. So to all the sport bettors, if you want to use our model, you have to see the halftime result and then bet accordingly. Yeah, then feed into our model. It will do. So yeah, usability can be improved if we conduct our model using pre-game data instead of in-game data like use like player data, team data, and previous 3 games. If I use them instead, I can predict 2 days later for the game which team is going to win. But now I cannot because I got to use in-game data. So, but however, this can be useful for sport betting website for the sport bettors to adjust the odds and also to be in their favor. Also check by according to the game stats. And after that, you'll be able to gain profit from it. So that's all for my assignment. Thank you very much for listening, and I appreciate doing this assignment and sharing it with you.